Hello learners, welcome back to another lesson of our introduction to statistics. So the lesson for today will be correlation analysis. We will be looking at correlation. We explain some important notes on correlation. We are going to explain the scatter diagram, explain correlation coefficient, and try to compare the scatter diagram and correlation coefficient. Correlation measures the strength and direction of a statistical linear relationship between two or more variables. So an example of this is a measure of correlation between height and weight of women in Uganda. We can also measure the degree of correlation by using Pearson correlation coefficient. So the coefficient symbol, which is R, can take any value from -1 to 1, and the interpretation will be, if it is -1, we denote it as perfect negative correlation. The variables tend to move in opposite directions. That is, when one variable increases, the other variable decreases. And if we have 0, that means there is no correlation. The variables do not have any relationship with each other. If the correlation coefficient is 1, which we denote as perfect positive correlation, that means that the variable move in the same direction. So when one variable increases, the other variable also increases. So this positive correlation is relationship between two variables which move in the same direction. That is, when one variable increases, the other also increases, and vice versa. So the important thing to know is that correlation measures the strength and direction of the linear relationship between two variables, but it cannot capture non-linear relationship between two variables and cannot differentiate between dependent and independent variables. So scatter diagram, we use this to examine whether there is correlation between two variables, and you will also need this first plot of scatter diagram to plot the correlation relationship. The scatter diagram assesses the relationship between the variables and determine whether they are correlated or not. So this is the diagram comparing the scatter diagram and correlation coefficient. So for perfect positive correlation, which is R equals 1, there is a perfect line graph moving upward, or if it is perfect negative correlation, it is a perfect straight line diagram but in descending order. So if you have a high positive correlation that the value could be 0.9, then you have a diagram as this, or a high negative correlation diagram as this. So we could see that they are opposite of each other. The high positive correlation and the high negative correlation, they are opposite of each other in the diagram. So if you have a low positive correlation, which is in the middle, 0.5, you have your diagram as such, and the opposite is also low negative correlation for minus 0.5. But for no correlation at all, there's no relationship between the variables, you have the diagram in this way. So now, we now go to our Jupyter Notebook to discuss further. This is our statistical thinking tool. This is our notebook for correlation analysis. So how do we get our correlation from Python? We use this keyword df standing for the name of your dataset, and this is the correlation, instantiating the correlation analysis. And the Python uses this Pandas attribute to estimate the correlation between or among the pair of continuous variables in data frame. So we use scatter diagram to show the relationship between these variables. So this is an example that we have a data set called Uganda women in .csv format, which contains the height and weight of 300 women from Uganda. So this is the name of the data set and it's also in our directory. So the task is to plot a scatter diagram of height against weight so that we can examine whether there's correlation between the two variables. Then we also calculate the Pearson correlation coefficient between height and weight of these Ugandan women. So the first thing to do is to import all the necessary packages, NumPy, our Pandas, the Matplotlib, and the Seaborn packages. We import them as they appear here, and we run to make sure that they are imported correctly and it is error free. So the next thing to do is we need to import the Somalian women data set and use the Seaborn package to plot the graph. So we have imported here and it is in a CSV. So we use the word read underscore CSV to read the data set. So we will examine the data set, which I told you earlier that it is usually a good practice to check the data set you have imported, whether it is the right data set that you want to use. So we could use that using the head. So we see that in our data set, it contains only the height and weight of Uganda women, and we could also check the tail end of our data set, and we could also see that it contains the height and weight. And don't forget that we said that there are 300 samples. So this 299 shows that we have imported the right data set. And you can also check just at a glance by using the shape keyword to give you the number of rows and the number of columns for the data set. Now let us use our scatter plot to detect whether there's correlation between the height and weight of women in Uganda. So we have used the SNMP to plot the graph using this SNMP plot function from Seaborn. We use it for the scatter diagram. So from the scatter diagram now, we could see that there is, this is a perfectly positive correlation. It is a strong correlation between the height and weight of Uganda women. So another example is we can also estimate this using the Pearson correlation coefficient by using, this is the name of the dataset, dot correlation insertion keyword. So if we do that, it has calculates the correlation coefficient using Pearson correlation coefficient function, and we could see that there is correlation because the value of weight here and the value of height, they are closer to 1. So the result of the Pearson correlation, we see that correlation on the same variable will always be 1, and our concern is to look at the correlation between height and weight, and we could see that this is the correlation between height and weight, which is what we have here. So another example that I'm going to be treating with you is a data set from a restaurant in Nairobi, Kenya to be precise, where they come and eat food, and after eating, based on the total bill the customer received, the server receives some tips. So the following variables are in the data set. We have the total bill, which is the cost of the meal in Kenya shilling, then the tip, that is the gratuity that is given to the server in Kenya shilling, then the gender, that is the sex of the customer buying the food, whether the customer buying the food is a male or a female, then smoker, whether the customer smokes cigarette or not. Then day means the day of the week of the party, while time is the time of the day, whether it is lunch or dinner. Then size means size of the party. So the task now is to import the data set from our data set folder. We calculate the pairwise correlation among these variables and we visualize this using the scatter diagram. So the first thing we do is that we import the data set, we read it, and we check whether we have imported the right data set with the right variables. Because from what we have here, we said that we have the total bill, then we have the tip, we have the gender, we have the smoker, we have the day, we have the time, and the size. So that means that we have imported the right data set. So now, since the name of our data set is called tips, then we can directly find the correlation using the pairwise correlation keyword. So from here now, we could see that the correlation between the total bill and tip is this value. Then the correlation between tip and size, this value. So we can plot a scatter diagram between tip and total bill, then tip and size. Let us do that using the plots. So from the diagram now, we could see that the value for the correlation is 0.215, which shows that there is almost no correlation between the tip and the total bill. So let us also check for the correlation between the tip and the size of the party. So we could see that there's no linear relationship between these two variables, that is the tip and the size, and the diagram looks like this because of the size of the party is categorical variable. So this is the class activity that I will encourage us to do, and it involves the partner penguin data, which contains size measurement of 3 penguin species observed in the 3 islands in the Palmer archaeology in Antarctica. So the first thing that you should do is that you import the necessary libraries, then you import or you read in the penguin data set, then you also create a pairwise correlation coefficient, and you plot the scatter diagram using all the code that we have done before. Thank you for staying with me on this video. Bye.